Here we want to use the epsilon delta definition of limit to prove that the limit of the function for x minus 2 is equal to 10 as x approaches 3. And so numerically, if we allow x right here to get closer and closer and closer to 3, then we see that the for x minus 2 is getting closer and closer and closer to 10. So as x approaches 3, y is getting closer and closer to 10. And so that's what this statement is saying. But we want to use the epsilon delta definition of limit to show that this statement is true. And so what that means is this. First, let's label the 4x minus 2, that's the f of x. And then the 10 here, we'll call it L. And then the 3 here, we'll call it C. And so to use the definition of the epsilon delta definition of limit, to show that this statement right here is true, we must show that for every given epsilon is just a small number like 0.01, then we must be able, for every given epsilon, we must be able to come up with a delta such that if x is inside of the interval c minus delta and c plus delta, then the corresponding y value is in the interval of L minus epsilon and L plus epsilon. This definition is also written like this. So when we say that x is inside the interval c minus delta and c plus delta, it's the same thing as saying the absolute value of x minus c is less than delta. And then similarly, when we say that f of x is inside the interval L minus epsilon and L plus epsilon, then it's equivalent to say that the absolute value of x minus L is less than epsilon. And then in the video, in clip part 1, we have shown why this is equivalent to this is equivalent to this already. And so, once again, we want to use the epsilon delta definition of limit to show that this statement is true. So we must show that for every epsilon, given epsilon, and then we must be able to come up with a delta such that if we pick an x from the interval c minus delta, c is 3, and c plus delta, then the corresponding y value or f of x is inside the interval of L minus epsilon and L plus epsilon. Once again, L is 10. And so let's start with an example. So let epsilon be given as 0.01. Then now we must come up with a delta such that if we picked an x from the interval 3 minus delta and 3 plus delta, 3 is the c right here, then the corresponding y value must be inside the interval of 10 minus 0.01 or epsilon, and 10 plus 0.01, which is the interval 9.99 and 10.01. And so let's let delta, so we choose a delta of 0.001. And then 3 minus delta, 3 plus delta is 2.999 and 3.001. And now if we pick an x, pick the number from this interval, then we must show that the corresponding y value is inside of this interval. And so let's pick a number from this interval. Let's pick 2.9999. Then the corresponding y value would be the function evaluated at 2.9999, which comes out to be 9.9996, which is inside of this interval right here. But to prove that this is true using the epsilon delta definition of limit, we must show that this process right here is true for any epsilon. This is just one value of epsilon. We must show that it's true for any epsilon. And therefore, to do that, we will try to come up with a formula that relates epsilon and delta, so that once epsilon is given or is specified, then we can use that formula to formulate delta. Because to use the epsilon delta definition of limit, we must show that it's true for any epsilon. And so notice the following. The statement f of x minus L less than epsilon is the same as, which means that 4x minus 2, because f of x is 4x minus 2, and then L is 10. And 4x minus 2 minus 10 is 4x minus 12. Common factor is 4, so we get 4 times the absolute value of x minus 3, and then divide both sides by 4, then we get x minus 3 is less than epsilon dividing by 4. And so the statement f with the absolute value of x minus L less than epsilon is equivalent to the statement absolute value of x minus 3 less than epsilon dividing by 4. And once again, the objective is, once epsilon is given or is specified, we need to come up with a delta such that if x is inside the delta, such that x is inside the interval 3 minus delta and 3 plus delta, then the corresponding y value must be inside the interval 10 minus epsilon and 10 plus epsilon. And so we have to come up with a delta that must meet this condition right here, which is the same as this, and this condition at the same time, because this condition is equivalent to this statement right here. And so we look at this statement and this statement, we see that the similarity is the x minus 3. So we can try to let delta be epsilon over 4. And so we will let delta be epsilon over 4. And we must show that this will lead to the statement, will lead to the statement absolute value of x minus L is less than epsilon. And so we've chosen we've chosen the delta to be epsilon over 4. And so now we must show that if we picked an epsilon, that we picked an x from the interval 3 minus delta and 3 plus delta, then the corresponding y value would be inside of this interval right here, which is equivalent to saying f of x minus L is less than delta epsilon. So x minus x inside of the interval 3 minus delta and 3 plus delta is explained earlier. This means that the absolute value of x minus 3 is less than delta. And we can go through that process again right here. This means that x is between there and there. And then if we subtract 3, then this is saying that x minus 3 is between negative delta and delta. And using absolute value notation, then we have absolute value of x minus 3 is less than delta. But we have chosen delta to be epsilon over 4. And now multiply both sides by 4, And then we'll get 4x minus 12. And then we can rewrite this as 4x minus 2 and minus 10. But 4x minus 2, that's f of x. And then 10, that's the L. And so we have just shown that if we let delta be epsilon over 4, and then this will lead to the f of x minus L is less than epsilon. And therefore we have just proved that the limit of 4x minus 2 is equal to 10 as x approaches 3. And so that's what it means to prove this statement right here using the epsilon delta definition of limit. And once again, what that means is that once epsilon is given, then we must come up with a delta such that if x is inside of this neighborhood right here, then the corresponding y is inside of this interval. So in this case, we have chosen delta to be epsilon over 4, and it will lead to f of x minus L less than the epsilon. And so this is the relationship, this is the formula that relates epsilon and delta. And so anytime the epsilon is given, then we just let delta be epsilon over 4. And so in an earlier example, we let epsilon be 0.01. Then we can just let delta be 0.01 divided by 4. And that will lead to the absolute value of f of x minus L less than epsilon. And therefore, that's how we prove this statement using the epsilon delta definition of limit.